Hey guys, our goal for today is to be able to solve absolute value inequalities. A good essential question is to ask yourself, how is an inequality different from an equation? Alright, I'm going to go ahead and tell you that answer. An equation gives us an exact value. If you remember last week from Wednesday and Thursday when we were talking about solving absolute value equations, we had either 0 answers because both answers were extraneous, 1 answer because one answer worked and one was extraneous, or 2 answers because both of them worked and neither were extraneous. Alright, well the thing is about an inequality is it's a range of answers, okay? Because we're going to get answers like x is less than 4, x is greater than negative 5. Alright, you'll notice that when I say x is less than 4 or x is greater than negative 5, those answers are ranges. They're not specific values, they're ranges of values. Okay? So let's look at this first example. 3 times the absolute value of y minus 9 is less than 27. Okay, so what this question is getting at is it's saying 3 times this is less than 27. In other words, we're looking for values of y, that's what we're going to solve for, that if we were to plug them in, they would make the left side become numbers less than 27. Okay? So let's go ahead and solve this. Well, even though it's an inequality, we still solve it in the exact same manner that we solved equations. Alright? So I'm going to start off dividing both sides by 3, because 3 is multiplying the absolute value inequality, and I must get the absolute value by itself first before I can continue on. So these 3's cancel, so now I have the absolute value of y minus 9 is less than 9. Alright, now that I've solved for the absolute value, it is crucial that I set up 2 inequalities. One where everything is the same, so y minus 9 is less than 9, and the other one where I'm taking the negative version of the other side. But when you're dealing with inequalities and you negativize something, that's not a real word, I just made that word up, you have to flip the inequality symbol. So I flip this to being a greater than negative 9. So now I need to solve for y. I highly encourage you to pause and try to solve for y on both of these right now on your own. To be good practice. So hopefully you just unpaused and you have your answers for y and you just want to check them. You would add 9 to both sides. That gives you y is less than 0. Add 9 to both sides. Oh, not 0 over here. I'm a dummy with a tummy. 18 over here. My apologies. 18 over here. And y is greater than 0 over here. Okay. Now you need to check these. Well, what's a number that's less than 18? Well, I don't know. It's easy. 10. Great. So I could say 3. Remember, you're going to plug back into the very, very original thing. So 3 times the absolute value of 10 minus 9. And we're going to see if that gives us a number that is less than 27. And it does. So when y was less than 18, such as the number 10, it worked. It gave us a number that was less than 27. But what about when y is greater than 0? Well, didn't I just check that? What was the y value I just checked? A y value of 10. Is 10 greater than 0? Yes. Therefore, when I plug 10, it fits both requirements. Awesome. So they both work. Neither are extraneous. So now what I want to do is I want to plug it on a number line. Okay? Well, again, as I like to say in class, work smarter, not harder. I'm not particularly particular about your number lines, so I just draw 2 tick marks, 0 and 18. And I know that y must be less than 18, so that means it gets an open circle because it was less than, not less than and equal to. And y is greater than 0, so that means it gets an open circle. It says y must be less than 18, so it's going to the left. But it says y must be greater than 0. To be greater than, that's going to the right. So they meet here in the middle. Alright. So what I just drew right there is a graphical representation of all your possible answers. All your possible answers are numbers that fall between 0 and 18. Okay, let's go on and try our next example. Okay, our next example is 6 times the absolute value of 2x minus 1 plus 5 is greater than or equal to 47. Step 1 for any absolute value problem is get the absolute value by itself. So start by subtracting 5 on both sides. So this gives me 6 times the absolute value of 2x minus 1 is greater than or equal to 42. So the next thing you want to do is divide both sides by 6. So now we have the absolute value of 2x minus 1 is greater than or equal to 7. Perfect. Now I have the absolute value by itself, so I can set up my 2 equations. 2x minus 1 is greater than or equal to 7, and then 2x minus 1 is less than or equal to 7. Alright, now I'm going to solve for x. So I'm going to add 1 on both sides. So I'm going to get 2x is greater than or equal to 8. I'm going to divide by 2 on both sides. So I'm going to get x is greater than or equal to 4. Alright, now I'm going to repeat that same process over here. I'm sorry, guys. I'm a dummy. What was I supposed to change over here? Hopefully you already caught it. I already wrote my original one. Oh, wait. I didn't mean to erase that part. Here, 2x minus 1 is less than. I did change the inequality sign, but what if I forget to do the 7? I forgot to make it negative. Alright, so now I want to solve for x here, so I'm going to start by adding 1. Adding 1. So I have 2x is less than or equal to negative 6. Then I want to divide both sides by 2, so I get x is less than or equal to negative 3. Alright, so now I need to check both of these. So what's a number that where x is greater than 4? 5. That works. So we're going to plug it back into the very, very original. So we get 6 times the absolute value of 2 times 5 minus 1, and then plus 5. And if this works, I should get a number that is greater than or equal to 47. And I got 59, so it works. Alright, so now I'm going to check this other one. X is greater than or equal to, x is less than or equal to negative 3. So I can say 6 times the absolute value of 2 times, I don't know, what's a number less than negative 3? Negative 5? Negative 5 minus 1 plus 5. Press enter, and I got 71. Is 71 greater than or equal to 47? Yes, it is. So now, since both these work, I'm ready for my number line. Alright, so I draw myself a number line. 4 and negative 3. Alright, since both of these answers have equal to bars, I know that above both of these, it's going to be closed circles. Alright, so let's start with the 4. X is greater than or equal to 4. So that means x is going to the right from 4. X is less than or equal to negative 3. So that means x is going to the left. So x is less than negative 3 or x is greater than 4. Greater than or equal to. X is less than or equal to negative 3 or x is greater than or equal to 4. Alright. Okay, let's do one more example, then we'll wrap this video up. So, we have the absolute value of 3 minus 9a is less than or equal to 60. Well, you'll notice that we already have the absolute value by itself. So that means I can jump straight into setting up my two inequalities. So 3 minus 9a is less than or equal to 60. And then I can say 3 minus 9a is greater than or equal to negative 60. So now on both of these, I can solve for a. So I start off by subtracting 3. So I get negative 9a is less than or equal to 57. Okay, to finish off for a, I need to divide both sides by negative 9. Alright, so I get a. I'm dividing by a negative. What has happened to the inequality sign? That's right, it has to flip. So I flip the inequality sign, and this reduces down to being negative 19 over 3. Alright, subtract 3 over here, subtract 3 over here. So I get negative 9a is greater than or equal to negative 63. Divide both sides by negative 9. Divide this side by negative 9. So I get a. Ding, 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 ding. You're dividing by a negative, so you must flip the inequality sign. And that's a 7. Okay. So now we got to check them. So let's check a is greater than or equal to negative 19 over 3. What's a number where a is greater than a negative 19 over 3? Hopefully it was just like, oh, 0. Duh. 0 is greater than that because 0 is positive. Well, it's neither negative nor positive according to some people. But it's still bigger than a negative number. Alright, so then we can say 0. And that gave me 3. Is 3 less than or equal to 60? Yes, it is. So that one worked. So 0 worked. Is 0 less than or equal to 7? Yes. So I already checked it for both of these. Woohoo! So now I can just jump straight into my number line. So I draw myself a number line. Negative 19 over 3. 7. Alright, it says a is greater than or equal to, so equal to bar. A is less than or equal to, so equal to bar. And they're meeting in the middle. Alright. So there we go. Alright guys, hope this video made sense. I did try to make it fast and sweet, so hopefully it was all good. Please let me know what doesn't make sense so I can come back and kind of help you out. Thanks.